2.3. Apply deductive reasoning. What is deductive reasoning? Deductive reasoning is using facts, definitions, accepted properties, and logic to form a logical argument. Okay, laws of logic. You may have had these before in a logic class. So if you did, that's cool, and these will be easy. So the law of detachment says if the hypothesis of a true conditional statement is true, then the conclusion is also true. So that might be if an animal is a bird, then it has wings. So the law of detachment says if I truly do have a animal or a bird, then that bird will have wings. So I can, it just, if it's true, then the conclusion is also true. So law of syllogism. If hypothesis P, then conclusion Q. If that is true, and also, if you flip it around and remember what that is called, the converse. If hypothesis Q, then conclusion R. Oh, not flipping around, we're adding something else. Then hypothesis P, then conclusion R. So this statement is always true. So this is syllogism. So if a quadrilateral, if a shape is a quadrilateral, then it has four sides. And then I could write a second statement that says if something has four sides, then it has four angles. Then I could put them together and say if a quadrilateral has four sides, then switch over to the conclusion of the second one, it has four angles. So it's connecting the hypothesis of the first thing to the conclusion of the last thing. If both statements are true before, then this is also true. So let's use that in example 1. If two angles have the same measure, then they are congruent. You know that measure of angle A equals the measure of angle B. So, because measure angle A equals measure angle B satisfies a hypothesis of a true conditional statement, then the conclusion is also true. So we could write that angle A equals, not just equals, but is congruent to angle B. Next one. Jesse goes to the gym every weekday. Today is Monday. First, identify the hypothesis and conclusion of the first statement. The hypothesis is if Jesse goes to the gym every weekday. Oh, if Jesse goes to the gym, it's a weekday. Okay. If Jesse goes to the gym. Okay, let me just try to rewrite that. Jesse goes to the gym, then it's a weekday. Okay, so the second statement is today's Monday satisfies the hypothesis of the conditional statement. So you can conclude that Jesse will go to the gym. Now I kind of wrote this backwards from what they did, so you might have caught this. Today is Monday. It's not really my hypothesis up here. So my hypothesis I wrote was if Jesse goes to the gym every weekday. If Jesse goes to the gym, then it's a weekday. So they wrote it backwards. Okay, a little bit confusing. I'm sorry. Okay, using the law of syllogism. If possible, use the law of syllogism to write the conditional statement that follows from the pair of true statements. Okay, A. If Ron eats lunch today, then he will eat a sandwich. If Ron eats a sandwich, then he will drink a glass of milk. So, the conclusion of the first statement is the hypothesis of the second statement. So you can write the following. If Ron eats lunch today, then he will drink a glass of milk. Okay, next one. If x squared is greater than 36, then x squared is greater than 30. And then the second statement is if x is greater than 6, then x squared is greater than 36. These are both true statements. So, so we can notice that the conclusion of the second statement is the hypothesis of the first statement. So conclusion of the second statement is hypothesis of the first statement. So we can write these together and take out that, take these out, the ones that match. So we can say that if x is greater than 6, then x squared is greater than 30. Okay, C. If a triangle is equilateral, then all of its sides are congruent. If a triangle is equilateral, then all angles in the interior of the triangle are congruent. Okay, they both have the same statement. If a triangle is equilateral. But one's in the position of the hypothesis, and the second one is also in a position of the hypothesis. So we can't use these for a law of syllogism statement because neither conclusion is the same as the other statement's hypothesis. So you can't use the law of syllogism to write a new conditional statement because it may not be true. Okay, checkpoint. Complete the following exercises. Start the video again when you're done. Okay, example 3. Use inductive and deductive reasoning. What conclusion can you make about the sum of an odd integer and another odd integer? Well, we're going to use inductive reasoning and start looking for patterns. So remember that integers are positive, negative whole numbers. Negative 3 plus 5 is what? 2. Negative 1 plus 5 is 4. 3 plus 5 is 8. Ooh, do we start seeing a pattern here? What do we know about 2, 4, and 8? They're even numbers, aren't they? Let's see if our pattern stays true with some different examples. So let's use both negatives. Negative 3 plus negative 5 is negative 8. 1 plus negative 5 is negative 4. 3 plus negative 5 is negative 2. So we can write a conjecture from here. An odd integer plus an odd integer is an even integer. Step 2. Let n and m be any integer. Use deductive reasoning to show that the conjecture is true. 2 times n and 2 times m are even integers because any integer multiplied by 2 is even. So I'm using facts to build this up. This is deductive reasoning. So now let's go back to the facts that we know to prove it. 2n minus 1 and 2m plus 1 are both odd integers because 2n and 2m are even. Okay. So anytime that I multiply any number by 2 and then either take one away or add one to it, we're going to get odds. So here's how to prove it. 2n minus 1 plus 2m plus 1 represents the sum of an odd integer. 2n minus 1 and an odd integer, 2m plus 1. Then let's write it all together. 2n minus 1 plus 2m plus 1 equals 2 times n plus m. Okay, do we see how we got that? We just did algebra with that because negative, we could drop the parentheses, and then negative 1 plus 1 is 0. So then I could say 2n plus 2m, and then I just factored the 2 out. So the result of a product of 2 and an integer n plus m, so 2 times n plus m is an even integer. Okay, it's using algebra with definitions to prove your answer. The sum of an odd integer and an even integer is always even in the last blank. Okay, checkpoint. Use inductive reasoning to make a conjecture about the sum of a negative integer in itself. Then use deductive reasoning to show the conjecture is true. Okay, so make up some negative integers and add them to itself and see what you get. Then let's substitute, instead of using real numbers to do deductively, let's substitute letters like n or x and say why algebraically we could prove that its conjecture is true. Okay. Again, these are a little weird, so give it a good try and think about it. Start the video when you're done again. Okay, example 4, reasoning from a graph. Tell whether the statement is a result of inductive reasoning or deductive reasoning. Explain your choice. The runner's average speed decreases as time spent running increases. Okay. What are we using? Are we looking at patterns and then making a conjecture? Or are we looking at data and then using a logical argument? So this is patterns, isn't it? So this one is inductive. Move it up again. Alright. Now, B. The runner's average speed is slower when running for 40 minutes than when running for 10 minutes. Okay, on this one I'm using specific data. And so when I have specific data, it's going to be deductive. We're comparing values that are given on the graph. And they have to be on the graph. Okay? We're not going further in the future or going backwards. We're just saying on this graph, this is evidence that I can tell you that I know is true. So checkpoint, do those two checkpoints and bring it to class tomorrow.